Okay, hello everybody, and thank you for joining me today. My name is Amelia Downs. I'm a staff engineer at VMware, and I've been a contributor to Cloud Foundry since 2016, and I'm tech lead of the CFF Application Runtime Platform Working Group, and I'm so sorry that I can't join you in Heidelberg today. Today, I'm going to talk about an introduction to the Application Runtime Platform Working Group. Wow, what a mouthful. I'm going to give you a behind the scenes on some maintenance work that we've been doing. And I'm going to discuss some new and future features like distributed tracing, readiness health checks, and more. So what is the Application Runtime Platform Working Group? Well, Cloud Foundry, the foundation, has 8 working groups. And this one, the App Runtime Platform, that's the one that I'm a tech lead for, which is what we'll be discussing today. So this working group has a whopping 153 repos. These repos are split into 6 areas. And amongst these areas, we have 35 unique approvers and 4 reviewers. Our 6 areas are, maybe you've heard of some of them, Diego, docs, guarding containers, logging and metrics, networking, and networking extensions. Our working group meets the first Wednesday of every month, and we alternate between a European-friendly meeting time, so our European colleagues don't have to stay at work too late, and a USA West Coast-friendly meeting time, so our West Coast colleagues don't have to wake up too early. The time changes can be confusing, but you can always trust the CFF community calendar to be accurate. Anyone is welcome to join these meetings and add items to the agenda, not just approvers and reviewers. So I look forward to seeing you there. I also invite everyone to join our Slack channel for general updates. So now that I've introduced you to our working group, let's look at some of the behind the scenes work that we've been doing. This is work that you might not always hear about, and it might not always get the biggest spotlight, but it's so important for keeping the Cloud Foundry ecosystem healthy. And because this is my talk, I'm going to bring up the subject that I'm most passionate about, which is bumping Go. Of course, if you know me, you knew this. So a lot of our code is written in Go in this working group. And one of the things that we have to deal with is that Go updates frequently. So there's a new minor version of Go every 6 months. And with Go's versioning scheme, they allow breaking changes in minor versions. So that means every 6 months, a new version with a new breaking change is released. Each minor version of Go is supported for only 1 year, and there are no exceptions to that. So there's no long-term support or LTS version for Go. And all of these factors together mean that in order to keep our users on supported versions of Go, we have to keep a pretty strict timeline. And that timeline looks something like this. So for example, in August of this year, August 2023, the next version of Go will be released, version 121. At the exact same time, Go 119, 2 versions prior, will go out of support. So once that new version comes out, we get to work. We pull that new Go version into the develop branches of our code, we run tests on it, and of course, we read release notes and look for changes that could affect our users. Often we end up making changes to our code to make sure our users don't experience breaking changes, or at least warned. Once we run our tests and evaluate the release notes, then we cut a new release using the new Go version. Great. I wish that was the end of it, but sadly, that's not the end. But because sometimes Go changes things that we didn't know would affect users. For example, we did not know that there were a lot of users that were sending traffic with duplicate transfer encoding headers. So when Go became stricter with security requirements around these headers, many users' requests started failing. So when a user finds a breaking change like this, they might roll back to code that uses an older version of Go, in this case, 120, for this hypothetical situation. Then our working group works to handle this new Go behavior in a better way to shield our users from the change as much as possible. And once we release that code with a fix, then our users can upgrade. And ideally, all of those steps happen before the next version of Go is released. Because if we don't do all of those steps between August 2023 and February 2024, Then when the user rolls back to use Go 120, they will not be on a supported version of Go. So we've been working hard to make sure all of these steps happen as quickly as possible. So when we do this in a few ways. First, we do this by catching breaking changes before they actually break things, which means reading and evaluating release notes for every minor version and making changes to our code based on them. For example, you probably did not notice any of the following breaking changes to Go. And if you did, you got a nice error at template rendering time instead of a runtime error that took down your foundation. For example, when TLS 1.1 and 1.0 were disabled by default, or when they changed IP parsing standards with leading zeros, or some changes to SAN requirements. Hopefully you didn't notice any of those. Unfortunately, we're not perfect, and sometimes we do miss things and things do go wrong. This most recent change unexpectedly gave some users some grief recently. But this is why it's so important to try to bump Go as quickly as possible, so that when users run into issues like this and operators roll back, they're still on a supported version of Go, fully up to date with security patches. We also automate bumping as much as possible. Minor release bumps are partially automated, and they aren't fully automated because of what I just talked about, right? We have to do that manual step of reading release notes and making changes first. And our patch release bumps are completely automated. So every time Go releases a new patch, it automatically gets bumped in our releases. And all of this runs in a pipeline, of course. And lastly, we also document our Go versions. So we add the Go version to the release notes so that it's easy to discover which version of Go a certain release is using, which looks something like this. And all of this has really paid off because we are getting faster at bumping Go. For Go 1.16, which was released in February 2021, we cut a new routing release using Go 1.16 in May of 2021. So this Go bump took us 101 days. Obviously, we have to bump Go in many other releases as well, not just routing release. But routing release is often the most difficult and the last to be bumped because Gorouter is very exposed to end user interactions, which we don't control. So we often make the most code changes in routing release. For Go 1.17, which was released in August 2021, it took us until February 2022 to bump routing release to use it. Now, one was pretty difficult, required a lot of changes, and it took us a whopping 172 days. Go 1.18 took us 134 days to bump. Go 1.19 took us 67 days to bump. This is where I got a little bit more interested in making sure we do this right away. So we got into the double digits, which is pretty exciting. And most recently, the current latest minor version for Go 1.20, it only took us 21 days to bump, by far our fastest bump yet. I also wanted to share another success story around this automation. In 2022, I warned the logging and metrics team that 2 of their components might be vulnerable to a CVE that Go had patched the night before. Thanks to their pipeline automation, they'd already bumped Go on develop and had already tested it for both of their at-risk components. All they needed to do was click publish to get their components released with new Go security patches. This whole anecdote, this whole story and encounter took less than 10 minutes, which is awesome that we can get fixes out so quickly. And even though Go is my passion project, it's not the only thing we care about keeping up to date. We also care about all of our dependencies, of course, which is why we've begun adding some automated CVE scanning for our releases. Of course, in concourse pipelines. These pipelines use SIFT and GRIPE to open source projects to create software bills of materials or SBOMs and detect CVEs from those SBOMs. So when a dependency has a CVE in it and the pipeline goes red like this, we can be notified and we can make sure to fix it, get it secure, and we can make that pipeline go green again. Can you tell that I really love doing this maintenance work? But I'm told that people also like to hear about features as well, and we build those too. So I'm going to talk about a handful of new and upcoming features, but let's get started with this new feature, log rate limit quotas. As you know, apps can produce a lot of logs, and those logs take up space. That space costs money. It can be hard to determine the worst offenders, and the Cloud Foundry wide log rate limit doesn't allow for different rules for different apps. And that's why there are now log rate limit quotas. So now you can configure app log rate limit quotas per org, per space, or per app. Here's an example of how to configure it via the create org quota CLI command. And when an app exceeds its limit, it warns the app dev via a log message, and it warns the operator via a metric. That way you can track down those pesky, noisy apps. So with these quotas, you can lower your log volume, identify noisy apps, get warnings when limits are being enforced, but important apps can still have unlimited log volume. And that one noisy Java app erroring and logging a massive stack trace for every request will no longer cause log loss for all the other apps in the system. You can check out the docs to learn more about this feature. Another feature that's coming soon that I'm excited to tell you about is distributed tracing. So let's say something goes wrong. How do you know what logs to look at? There are so many logs and so many components, and occasionally, perhaps the docs are lacking, and it's annoying to line up timestamps amongst those many logs to try to figure out which logs are relevant, even though those timestamps are now all using the same human-readable timestamp format. So what logs do you look at? Let's say our developer runs CF stop on her app. How would you debug if something went wrong? Given that I've worked on Cloud Foundry for over 7 years, I know that the path that traffic takes is first it hits the load balancer, then it goes to Gorouter, then to the cloud controller, then to the BBS, and then to the rep. So if something went wrong, I would look in those logs first. However, I would not expect every CF user to know this off the top of their head, which is why I would like to introduce distributed tracing. Now some actions will be correlated with a trace ID. But what does that mean? Well, now in the Gorouter logs and in app logs, there's a log line that shows the stop request to Cloud Controller from the CF CLI. Well, that log line will have always been there, but now it has a trace ID in it. So you can take that trace ID, and from there you can search for that trace ID in all other logs. Look, I found a matching one in the Cloud Controller logs. The log line says stop app, and I can see that it's correlated to the exact same action because it has the same trace ID that was in the access log. Oh, look, I found another matching trace ID in the BBS. And so I know these logs are correlated to the same stop action. And yet again, I see the same trace ID in the rep logs. So I was easily able to find the relevant log lines, no matter how busy those log files are. And of course, you could do a general search of all logs for this trace ID so that you could identify the components and you didn't know exactly which component logs to look in like I did. So distributed tracing provides a GUID specific to an action to search for across all component logs, which will allow you to more easily trace logs through many components. This feature will be automatically turned on, but it does not cover every single code path. More updates are coming in the future. And docs to come soon. Once they are available, they'll be shared in the working group Slack channels, so you should join. Next, I want to preview our biggest feature on the horizon, which is Readiness health checks. As you may know, current health check failures result in drastic action. Currently, you can configure health checks like this in the app manifest, This example is using an HTTP health check that looks at the health endpoint and has a timeout of 2 seconds. And this current health check configuration actually results in 2 different types of health checks, a startup health check and a liveness health check. These health checks work something like this. First, there's the startup health check. And if that startup health check fails, then the app is never marked running and the app does not start. If the startup health check passes, then the app is marked running and the app has officially started. Then the liveness health check runs. If the liveness health check succeeds, then great. The app keeps running and chugging along. But if the liveness health check fails, then the app is stopped and rescheduled. So the current health checks kill the app immediately when the health check fails. There is no grace. There is no way to mark the app as healthy but not routable, which could be nice for apps that need to, for example, load a large amount of data at startup, or warm a cache, or for apps that depend on external services. No, this health check will immediately kill your app if it sees it's not healthy. Which is why we will be introducing readiness health checks. The new readiness health checks will be configured in a similar way to the current health checks. You can see these almost identical properties here. Also an HTTP health check being configured for the readiness health check. These properties will configure this readiness health check, which will look something like this. When the readiness health check succeeds, the app will be marked ready, and the route will be added to the Gorouter's route table. This means end users will be able to send traffic to it. But even when it succeeds, it never stops running this check. When the readiness health check fails, then the app is marked not ready, and the route is removed from the Gorouter's route table. This means end users will not be able to access the app. But crucially, the app is not stopped. And the readiness health check will keep running and will mark the app as ready once the health check passes again. So this new readiness check will enable and disable traffic flow. It will exist side by side with startup and liveness health checks, and it will give apps time to recover before routing to them again. This will give apps an easy way to deal with being healthy but not routable. And this will be optional and backwards compatible. There's an open source issue with this proposal, so please comment on it with any thoughts you may have. Now I want to do a quick lightning round of 2 more features that have come out recently. First, dynamic app renaming. Before, if you renamed your apps, it looked something like this. You rename your app, but oh, whoops, your metrics still use the old app name. That's annoying. You have to restart your app in order for your metrics to use the new name. Now, no more restarts needed. You rename your app, the metrics automatically use the new name. This should make blue-green deploys even easier. The second feature I want to highlight in our lightning round is that there is now an MTLS syslog drain option. You can read more about this in the docs. And to end this talk, I have a few requests for audience feedback from people in my working group. First, the logging and metrics team wants me to notify everyone again that the fire hose is out and syslog is in. Everyone should stop using the fire hose. Everyone should start using aggregate syslog drains. If you have any questions or want to raise any concerns about this, please do so in the logging and metrics channel in Slack. And our very own Matthew Coker wrote 2 blog posts about this as well that I highly recommend. Secondly, our PM Eric Malm is digging in to how people use availability zones in Cloud Foundry. So do you have a smaller single zone CF deployment that you would like to consolidate into a multi-AZ one, but you're holding back for some reason? Or do you have problems with the cross-AZ behavior inside of an existing multi-AZ CF deployment? If so, reach out to Eric or me in our working group Slack channel. So thank you everyone for listening to this talk and for learning about the stuff we've been doing behind the scenes, the Go bumps, the CVE scanning, for learning about our new features that are out right now, the log rate limit quotas, and the dynamic app renaming, and the MTLS syslog drain option, and for the features that are coming very soon, which includes distributed tracing and readiness health checks. But biggest thank you of all to all of the amazing App Runtime platform approvers. Here's all the ones with GitHub photos, at least. They've been doing this great work, and we couldn't do it without them. So thank you all. Have a great time in Heidelberg, and I hope to see you soon in person.